Mathematicians are cheaters because a lot of these things have been observed in the world around them. They don't necessarily come up with them. And then they notice something happening and they're like, hang on, I wonder if I can extrapolate this to kind of every case or a lot of different cases, not just the one I'm looking at. So yeah, it's kind of like running an experiment, but it's it's a bit more conceptual. Anyway, read this out for me, Jacob.
In a normally distributed set, the scores for mean is 23 and AC is 5. Approximately what percentage of scores will lie between 18 and 33?
So the important thing is this term here, normally distributed. Anytime you see this, you assume that your scores of data will resemble this shape. What kind of shape did we call it here? Bell shape, good, yeah. And in your photo, double check, it has the percentages of the certain standard deviations away. But the first thing I like to always mark in is the mean. So the mean in this case is 23. And they tell me that the standard deviation is 5. So x bar is 23 and standard deviation is 5. Now why that's useful is, why that's useful, try, is because then it allows us to find a certain percentage of scores away. For example, what can I fill in for this next boundary, Tamika? What number can I put in here?
It would be the 33.
Hold on. So I want to know the score that this boundary would be.
What?
So
28.
we know, yeah, 28. Why?
Because it's plus 5.
Good, right. So we know
I
that
went too far ahead.
we know that there's certain percentages in each kind of region, but those regions are separated by how many standard deviations away we are from the mean. Yes, Tom?
Yeah,
Why is it plus 5?
So we have two things we've been given. We've given the mean and given the standard deviation. In a normal distribution, it tells me that one standard deviation away, so that's 5 in this case, right? I have 34% of the scores. If I go one below, I also have 34% of the scores in this region. So what's one standard deviation below the mean?
18.
Exactly. So now, right, I know that, for example, between 18 and 28, there would be 34% plus 34% of the scores in this region. And I can keep going, right? I can go 33 up here, one more standard deviation away, and I can go one less standard deviation away. That would be 13. Now remember, it's all well and good to fill in this table, but we still have to answer the question, right? It's saying between 18 and 33. So all you have to do for this is identify where those scores lie on your normally distributed graph. You say, okay, I've got 18 here, and going up to 33. And so, now I just want to count up the regions for which are enclosed by those scores. So Jacob, what percentages do I have here?
34, 34,
Yeah.
13.5.
Good. So the total would be 34 plus 34 plus 13.5. And what does that give me?
81.5.
81.5. Well, no, so the answer is going to be D. Yeah, I just got one mark in the HSC. Right.
So that's a single mark question.
Did you want to do more?
No, it's just one.
Do we just add 34, 34 and
Yeah.
13.5?
That's it. That's what you're going to do.
Okay.
Now, that's all well and good, but what if I said, what percentage of scores lie between 21.5 and 23? Could you answer that question?
Pardon?
Sorry, I'm saying, if I asked you what percentage of scores lie between 21.5 and 23, what's the first thing you notice about 21.5?
It's not.
It's not on there. Yes, good. It's not on this. These scores.
34%.
Sorry. Good. Yeah. So if we were trying to find it, it would be somewhere here, 21.5. Squeeze it in there. It's actually situated in a specific spot. It's situated in the middle.
Does that mean you half? You go 34?
Yeah, we could do that, couldn't we? Right. So you could say, all right. Well, 21.5 is halfway between 18 and 23. It's a difference of.
What if it?
2.5?
Will you get a number where it's not in the middle?
I'll get into that in a second. But
Is mean the x with the line on
yeah,
top?
this means X bar.
Yeah.
Okay, so 21.5, because it is in the middle, it makes it easy to calculate, doesn't it?
Yeah.
I would know, for example, that it would just be half of 34, which is 17%, right? Okay. And the way we worked that out was kind of intuitive, right? We just said, well, if we place 21.5 there, I know it's halfway between 18 and 23, so I could just half the percentage in that region.
Yeah.
And as Tamika said, well, what if it's not exactly halfway? And so we want another method to do this. And there's two ways you can think of it. You can think about it mathematically, or you can try and think of it just visually from the graph. Let's do it this way first, okay? If you wanted to find out how many standard deviations away 28 was from 23, pretend we didn't know that already. What kind of calculation could you do to work that out?
Oh no, I tried, but I went.
Yeah.
23 minus 18,
Oh yeah.
and then that gave 5.
Yes.
Is that right?
Well,
Or is it-
remember, how many standard deviations away is 28? Is 18 from 23? How many standard deviations away is
One.
it? It's 1. Okay.
Yeah.
So you said 23 minus 18. That gives you 5.
Yeah.
But that's not 1, is it?
No.
What does 28 minus 23 give you?
5.
It also gives you 5. And it's also 1 standard deviation away. What about 33 minus 23?
10.
10.
2.
And that's 2 standard deviations away. Can you see the
Wait, what are we
relationship?
trying to do?
I'm trying to highlight something that's going to come up. Because the whole problem of this was when I asked you the 21.5, how many standard deviations away was it initially? We could only do that visually from the graph by trying to work it out. Now we want a kind of mathematical definition. So I'm trying to build this intuition. I'm saying that the difference between 28 and 23, that was 5, you said? And that's 1 standard deviation. 33 and 23, that difference was 10. That's 2 standard deviations away. Can you see a pattern that's starting to emerge?
Yeah.
28 minus 23 equals to 5. That corresponds to 1 SD. 23 minus 18 also equals to 5, which is 1 standard deviation away. 33 minus 23 equals to 10, which is 2 standard deviations away. And last one, 23 minus 13 equals to 10, which is 2 standard deviations away. And earlier I said that mathematicians, they look for patterns, right? And this is one example here. Can you see a pattern starting to emerge?
Yeah, 1, 2, 2.
Yeah?
3, 3.
And the numbers are corresponding, aren't they?
Yeah.
When you have 1 standard deviation, you have a difference of 5. And when you have 2 standard deviations, you have a difference of 10. What are these multiples of?
10.
5.
1.
And why is 5 an important number in this particular?
Just the deviations there.
Good, it's the standard deviation. So, the Z-score allows you to tell you the number of standard deviations.
What's the Z score?
I'm about to tell you.
Oh.
I'm about to tell you. So the Z-score is a new term that we introduce. It is the number of standard deviations away from the mean. Now, intuitively, you might be just thinking, well, can't we just count it? Like, doesn't the question just tell us? But remember, when I gave you 21.5, it wasn't initially clear how many standard deviations it was
So you use
away.
the Z-score to figure it out. That
Good.
makes sense.
Yes, but the Z-score, right? The Z-score has a somewhat complex mathematical definition. But all you have to think about is what you guys have just done here. You're trying to find out how far away your score is from the mean, because that's what we're looking at. But the Z-score is telling us how many standard deviations away. So we have to do another particular thing. If I want to go from 5 to 1 and 10 to 2, can you see what I need to do?
Multiply by 5. No.
Multiply by 5?
1.
Divide by 5. So, here's the last piece of the ingredient, okay? The last piece is we take our score and we subtract the mean. I should say score. The score, I think they use X, sorry. And what do we have to divide by? Run again, Jacob?
Just standard deviation.
Good, the standard deviation. So, I'll write this out in words as well. So you take the score, subtract the mean, and divide by the standard deviation. And that's a Z-score. Now, there's a particular placement. I've actually placed the score subtracting the mean, and we didn't always have that. I'll show you why we do that in a second.